Positive or negative?
That would be positive. No, negative.
Negative. In other words, the problem is basically minus 12 plus 5, right? Okay. Well, when you're adding a positive and a negative, you basically subtract the two numbers and you put the sign on it of the bigger number. So when you have a minus 12 plus a 5, I'm going to subtract them to come up with 7. And then I'm going to look which one has the bigger sign. The 12 is the bigger number, so I'm going to use the minus sign. All right, what's this?
That would be a positive 9. Positive.
If you're trying to multiply 11 times 12, multiply 10 times 12, that's 120. And then add one more 12 to it. So it's going to be 132, positive or negative?
Positive. That would just be 8, right?
Yeah, you got it. No, you're getting better at these for sure.
Why, thank you.
Remember, if I'm adding a positive number and a negative number, you subtract the two numbers. So the answer is going to be 1, and then what sign goes with it?
Negative.
Negative, the sign of the bigger number. In other words, 8's bigger than 7, so it's negative 1.
Negative 7?
You got it. All right, let's go on. You are getting better at those for sure.
Yeah, I've been practicing them.
Well, good. I didn't think it was just from the 5 minutes we were doing every day, because I know that that's not enough practice to really matter. All right, let's review solving equations with one variable. And then, hopefully before we're done today, we'll be able to solve equations of two variables. Or not solve them, but hold on. Okay. Here, still one variable only. Which means when you only have one variable, you're always going to be able to come up with a numerical answer for x. In other words, if I have one equation and one variable, I can solve it. We might have even done this. I'm not sure. I don't think we did. But what would your normal course of action be here?
Well, I would multiply what's in the parentheses by 3/4.
Okay. What do you get? Let's do that.
Well, are the 4/5 and the x, are they combined?
Well, they're being multiplied together. In other words, when you don't see anything in between a number and a variable, that always means they're being multiplied. Okay? So I have to multiply the 3/4 times, all you really have to do is multiply the number times the number.
So
what's 3/4 times 4/5?
So 12/20.
Do it the simpler way. Reduce before you multiply.
Isn't it 12/20?
It is, but there's an easier way to do it. In other words, if I want to cancel that 4 with that 4, leaving a 1 in both cases, I can do that. And now the answer is 3/5, which is the same number as 12/20. It's just already reduced. You see why I can cancel the 4s? In other words, as long as one's in the numerator and one's in the denominator, I can divide the top by 4 and divide the bottom by 4. When I say cancel, I'm reluctant to just do that because what's really left behind is a 1. Okay? But regardless, I end up with 3/5 x, which is the same as 12/20, but you would have then had to reduce the 12/20 down to 3/5. And then what's the second term you get?
This one's a little harder.
Not really. What's 3/4 times minus 2? Multiply numerators. Remember that minus 2 always has a 1 under it.
Oh, so it'd be positive 6, right?
Well, what are multiply the numerators?
Negative.
Multiply the denominators?
It'd just be 4.
Okay.
Yeah, 4.
That's correct. But, again, we're going to have to simplify this. So let's simplify it before we multiply. What can I do to top and bottom to simplify this? Can I do anything with this 2 and this 4?
Divide them by 2.
Okay. That leaves a 1 there and a 2 there. Now, when you multiply numerators and denominators, what do you get?
You get, that would be just negative 3 and 2. Yeah, 2.
That's it. And that's what we would have gotten if we would have reduced minus 6/4. It reduces to minus 3/2. But it makes far more sense to reduce before you multiply than it does after you multiply. Okay, so that term is minus 3/2, minus 3/2 equals 11/4. What's the next step?
You would...
Remember what the goal is. The goal is to get x equals some number.
You would divide each side by...
No, not yet. Let's take, in other words, right now we have some number of x minus this number. Well, let's gather all the numbers on the same side to begin with. So how do I get rid of this 3/2?
Plus add 3/2 to each side.
Okay. That now gives me on the left 3/5 x equals, what's 11/4 plus 3/2? How do I do that? How do I add two fractions with different denominators?
You have to get them the same.
Okay.
So
What's the least common denominator going to be?
4.
Okay. How many fourths is 3/2?
2.
Okay, my common denominator is 4. Well, I have 11/4 there. What goes right here? In other words, how many fourths is 3/2 equal to? And how do I get it? How do I determine what that numerator is?
You just multiply, or not multiply.
You divide the 4 by the 2, which is 2, and then you multiply that by the numerator. So 2 times 3 is 6. So 6/4 is the same as 3/2. Only now we have a common denominator, and we can go from here. So what's 11/4 plus 6/4?
11/4. Then it'd be no, because that's 17. Yeah, 17/4.
You got it. What's the next step? There's only one more step needed to get to here.
Divide 3/5 to each side.
All right, which is the same as multiplying each side by what? In other words, you're correct. I'm going to divide 3/5. That's going to get rid of the 3/5, and I'm going to divide this by 3/5. But when you divide by a fraction, what are you going to really do? You're going to multiply it by the reciprocal of that, right?
Yeah.
In other words, even if I do it this way, that's going to cancel. And then how do I divide 17/4 by 3/5? I multiply it by 5/3 instead. Remember, when you're dividing by a fraction, you flip it over and multiply. But the better way really to look at this is, instead of dividing by 3/5, how about we multiply both sides by the reciprocal to begin with? See why that gets rid of the 3/5?
Yeah.
Yeah, because the 5's cancel, the 3's cancel, and I'm left with x. Okay? Now, on this side over here, I can't really do much with that. That's 85/12. And when I said I can't do much with it, it meant that I can't reduce it at all, simplify it, before multiplying. I can't divide top and bottom by any same number. And in fact, that is simplified. I cannot simplify that anymore either.
Can't you change it to a whole number?
Well, I could do that. No, you're right. 12 goes into 85 7 times, leaving one remainder. So you can change it to a proper fraction, but you don't really need to. As a mathematician, I consider this actually maybe a better answer than that. Just because this is all set to do anything with if you need to. In other words, if you need to multiply that by another fraction, you're ready to do it, as long as it says 85/12. When it's 7 1/12, frequently you have to change that to an improper fraction in order to do anything else with it. All right, let's go on. Let's go to 2 variables. Two variables is really not any harder than one variable, because you use exactly the same strategy either way. In other words, you just treat the other variable like it's a number almost. So if I need to solve this for x, I can solve it for either x or y. And it's worth knowing that I'm not going to come up with a number as my answer, because I have only one equation and I have 2 variables. You can't solve that. In other words, I can solve x in terms of y, but I can't solve it for a number. There's literally an infinite number of solutions to this equation. As long as you have 2 variables and 1 equation, you can never solve it for numbers. I can solve it for x, but what's going to be on the right side is numbers and y. Okay? So, let's try to get to here. First step.
Wouldn't you minus 7, or, yeah,
I'm trying to isolate that to begin with. So, in other words, the second to last step is going to be this. So, how do I get 7x all by itself on the left side?
You would plus 3y.
All right. So, my second step is 7x, since that cancels. 7x is equal to 8 plus 3y. In other words, there's no difference between solving this equation with two variables than if I had one variable. You just treat the y like it's not an x. Okay? What's the last row here? X is going to be equal to what?
11y.
No, these are not apples and apples. One's a number, one's a variable. You cannot combine them. I could multiply 8 times 3y to get 24y, but I cannot add them. So that's as simplified as I can make the right side. But,
Okay. So then it would be plus or minus 7 from each side.
What's the 7 currently doing?
Multiplying the x. Oh, so it would be
Divide. Okay, so I'm going to divide that term by 7, and I'm going to divide this term by 7. And I'm going to maintain my plus sign. So that's what x is in terms of y. It's 8/7 plus 3/7 times y. Okay? Now, let's go back and solve this equation for y instead of x. Well, a lot of times you don't know which variable you have to solve for. So you want to be able to solve for y also. So in this time, we're going to try to end up with y equals something. And on the right side are going to be numbers and x's. So what's the first step to try to isolate that to begin with?
Would it be plus 7? Or no, would it be minus 7 or times or divided by 7?
What's the 7x doing right now? Is it adding, subtract? Is it being added, subtracted, multiplied, or divided?
Multiplied.
Actually, it's being added. The only reason you didn't see it is because it doesn't have the plus in front of it. If I put the plus in front of it, which is implied, now you can see that it's being added to the left side of the equation. Even though it's the first term, it's still being added. So if I want to get rid of it, I have to subtract 7x. So my second line is minus 3y equals 8 minus 7x. With me?
Yep.
What's the final step?
The final step is to plus 3y. No, divide 3y.
By? Divide by what? Divide both sides by what?
3y. No, 3. Just 3.
How about negative 3? In other words, you always want your last step to be dividing by whatever that is. That's a negative sign there. Okay? So if I want to change the left side of the equation to just y, I have to divide both sides by negative 3. So what's this last line? Y equals what? In other words, by dividing the left side by negative 3, I get rid of the 3. Remember, we're not trying to get rid of the y. If I was trying to get rid of the y, I would just add 3y to both sides. I'm trying to maintain the y. I'm trying to get rid of the negative 3 multiplier. So what does this change to?
basically copy and paste that down there.
Well, yes and no, not really. In other words, the left part becomes negative 8/3. And notice that the negative sign is better if it's in front of the fraction. This negative 8/3 is the same as 8 divided by -3. But when I go to simplify that, what do I get? The right side.
The right side?
Is that going to become a positive or a negative?
That's going to become a positive.
Yes, exactly. Positive 7/3 times x. Okay, let's do one more with two variables. This is going to get into something more. This is going to involve factoring, which is good. This is a good place to introduce you to factoring. You and I haven't done much in the way of factoring, have we?
I don't so.
Okay. Solve this for y.
Plus x from both sides. Wait.
You're close.
How do you x from 1?
Hold on. You're close. In other words, I want to take this x and I want to get rid of it, right? I want to move it over. In other words, if I'm trying to solve for y, I want that to be the last line. So the very first thing I want to do is get rid of anything that's not with y. What's this x doing right here? Is it multiplying, dividing, adding, or subtracting to the left side?
I'm going to say adding.
Okay, so what do I need to do to move it?
Minus
x. Minus x. So now my next line reads xy equals 1 minus x. So what's the last step if I want to solve for y?
minus x.
Minus?
Oh, no, divide.
Divide by x. Remember, you always want to do the opposite of what it is doing. And right now, it is multiplying. It's multiplying the y. So I have to divide by x in order to get rid of it. Well, I got to divide that by x and that by x. So now those x's cancel. So I've got y all by itself on the left. What's this become? Simplify that.
1 over x. Minus 1.
Good. Very good. All right. Now, let's make the problem a little bit harder and solve for x. You can kind of see why that's going to make it harder, right?
Yeah.
Remember that when you solve for x, you do not want any x's on the right side of the equation. You want x's only on the left side. Which means I don't want to take this xy and move it over, because then I'm going to have x's on the right side also.
So would you divide by y?
You would factor out the x. In other words, let me show you. I'm going to divide by x, which leaves 1 plus y. Now, before we go any further, make sure you understand why that is the same as that on the left side of the equation. Multiply these two back together again, you get x plus xy, right? Okay. So all I've done is factored out an x. I haven't changed anything. I haven't moved anything. The second line of that equation is the same as the first line. It's just written differently. Now, what's my last step if I want to solve for x?
Don't you times
that's going back to this step. In other words, that's going backwards if we do that. Remember the last step of solving an equation. The last step of solving any equation is to usually divide by the coefficient, right?
Yeah.
Well, what's the coefficient here?
Isn't it?
Let me write it differently. Instead of writing it like that, let me write it like that. Same thing. 1 plus y times x, the same as x times 1 plus y. Now what's the coefficient of x?
X.
It's 1 plus y. In other words, if I take my entire left side and divide it by 1 plus y, and then the entire right side by 1 plus y, this 1 plus y cancels with that 1 plus y, leaving me with x. So the answer is x equals 1 over 1 plus y. And that's simplified. I cannot simplify that further. I cannot break it up into two fractions even. That's not the same as 1 over 1 plus 1 over y. So that's my answer in solving for x. But this time we had to do something different than we normally have ever had to do. You and I have never had to do what we had to do on solving this equation, which was to factor. And that's the next thing we need to talk about is factoring, which we will do at your next session. Okay?
Okay.
All right. I will talk to you later, Garrett. Bye-bye.